Hello everyone, welcome to JCE Connect. So in this particular session, I'll be solving some numerical problems on curved vane. So in previous lectures, we have derived some of the equations, that is a force exerted by jet on a stationary vane and as well as a force exerted by jet on a moving vanes. So we have equations with us. So by having those equations, so let us take some numerical problems and solve. So in this particular lecture, that is the first problem, I am taking a jet of water of 75 mm diameter strikes a symmetrical stationary curved vane at its center with a velocity of 24 meter per second and is deflected through an angle of 135 degree. Neglecting friction, find the force exerted on the plate in the direction of jet. See, so this in this particular problem, so they mentioned the symmetrical stationary curved vane. So let us write first the given data. So they given the diameter of jet, that is given as 75 mm. Then they mentioned the stationary curved vane and the velocity of the jet. Velocity of the jet is 24 meter per second and the jet is deflected through an angle of 135 degree. So here the curved vane given as, this is a curved vane and it is stationary, fixed one, and the jet is striking at the center. So for this, when the jet strikes, this jet having a velocity v, that is 24 meter per second, it is striking at the center. Then the water will glide over the surface and it will exit like this. Okay, so here when you draw it back tangent to the curve, this will be what? This angle is theta. Again, this angle is theta and this is a velocity v. This will be 180 minus theta. This is angle of deflection. Angle of deflection. So in this problem, angle of deflection is given. That is 135 degree is given. Therefore, 180 minus theta is 135 degree. Therefore, theta will be what? 45 degree. Since the jet is striking at the center of the vane and with a velocity of 24 meter per second, and with the same velocity it will exit because they given neglecting the friction. So you have to neglect the friction, and whatever velocity with which the jet is striking, it will living with the same velocity by making an angle of theta, and this theta can be calculated based on the deflected angle. So the deflection angle is given as 135 degree. So 180 minus theta is 135. So theta will be 45 degree. So we know that the equation force when the jet is striking at the center, Fx equal to what? Rho a v square 1 plus cos theta. This equation we have already know because this the first case we have derived the force exerted by jet at the center for the stationary vanes, and here area will be what? Pi by 4 d square, because the diameter of the jet is given. So area will be, substitute the value of diameter here, you will get area as pi by 4 into 0.075 whole square. You will get 0.00442 meters square. Then substitute the values in the above equation. In this equation, what we get? So rho is density of water, 1000 into 0.0044 into velocity is 25 square, then 1 plus cos of 45 degree. We'll get like this. So then simplify this one. You will get the answer as 4346.16 Newton. Okay. This is the answer. So the problem is very simple, but you have to remember only the equation. So in this problem, so this is the symmetrical stationary coordinate is given, and the jet was striking at the center. So let us take one more example. In this example, see, a jet of water 50 millimeter in diameter enters a fixed curved vein with a velocity of 25 meter per second at an angle of 40 degree to the horizontal. The jet leaves the vein at an angle of 30 degree to the horizontal. Assuming there is no loss of energy due to impact and the friction in the blade passage, determine the force exerted by the jet in the horizontal and vertical direction. So in this problem, let us first write down the given data, and the jet striking the curved vein like this. This is the curved vein, and it is striking at one of the tip, it is given, and the inlet that is given here. The water 50 mm diameter enters the fixed vein with a velocity of 25 meter per second at an angle of 40 degree. It is entering by an angle of 40 degree, and this velocity is 25 meter per second. Then, and also they have mentioned there is no friction loss, so water will glide over the surface and it leaves the vein. It leaves the vein by making an angle of 30 degree. It is given here. Since there is no loss in the passage of the blade, there is no loss of energy due to impact. So whatever velocity with which the jet is entering into the blade passage, with the same velocity it will be leaving. Since this is a fixed veins, so it is leaving with a velocity of 25 meter per second. So it is leaving with an angle of 30 degree. Then when you resolve it, you will get this one is, so V sine theta and V cos, you can take it as a pi, and this angle you can take it as a theta. You will get this as a V cos theta and this as a V sine theta. So this is an unsymmetrical case. So this is unsymmetrical about the x-axis. So let us solve this problem. So here diameter of jet is given 50 mm, and also inlet angle and outlet angles are given. So here again velocity is also given 25 meter per second. Then calculate the area, pi by 4 d square. Then the area will be you will get a 0.00196 meter square. This much area, calculate the area. Then angle made by the jet at the inlet at inlet theta will be 40 degree, and at outlet the angle made by the jet, that is pi, will be 30 degree. The angle made by the jet at outlet with horizontal will be 30 degree. Now the force exerting by the jet in x direction, Fx, we know the formula rho a v square, that is for unsymmetrical case we know that we already derived cos theta plus cos pi. Then substitute the values in this equation, so you will get the answer 199.28 Newton. And this is in x direction. Similarly calculate in y direction, that is Fy will be rho a v square sin theta minus sin phi. Then substitute all the values, you will get 174.91 Newton. Then finally calculate the resultant root of Fx square plus Fy square, and if you want you can calculate the direction of the resultant, tan inverse of Fy by Fx. So this is the answer. Actually they are asked only to calculate the force exerting by the jet in x and y direction. So these are the answers. So you have to understand which case is been given. So in this problem the given unsymmetrical case, because the jet is entering with some angle and leaving with some other angle, and the velocity is given, and also they have said there is no friction due to impact of the jet in the blade passage. This means whatever velocity with which the jet is entering, the same velocity it will be leaving. So once we know the angle of entry and angle of exit, we can easily get the horizontal as well as the vertical component, both at inlet as well as at the outlet. And we know the equation for the unsymmetrical case, and use that equation for both in x direction as well as in y direction, then get the forces in x direction and y directions. Okay, so let us take one more example. In this example, jet of water of diameter 50 mm moving with a velocity of 40 meter per second strikes a curved fixed symmetrical plate at the center. Find the force exerted by the jet of water in the direction of the jet if the jet is deflected through an angle of 120 degree at the outlet of the curved vane. So again, this is a similar problem which I have solved the first one. And let's write the first given data. So in this one, the data is given here as diameter of jet is given as 50 mm, and the velocity of jet is given as 40 meter per second, and here the jet is striking, this is the curved vane, the jet is striking at the center like this with a velocity of 40 meter per second, and the jet diameter is 50 mm, and the vane is fixed one, that is stationary. When the moment the jet strikes, because of the force exerting by the jet on the vane, so the vane receives the impulse force, and because of the impact there is no energy loss, and this in the blade passage has been assumed completely smooth, hence there is no loss of energy here, and the jet will be leaving with an angle of that is a deflection angle has been given here. If you take it back, this is the deflection angle given, it is deflecting with an angle of 120 degree, and this angle becomes 60 degree, and this is the component, and this is the velocity. We get v sine theta here, if this is also theta, and this is v cos theta. Okay, then with this the area of the jet area will be pi by 4 d square. We get the answer as if you substitute the jet diameter here, so we get area as 0.001963 meters square. Then the force in x direction, fx equal to, we know the formula rho a v square 1 plus cos theta, and here we have to calculate the theta because the deflection angle is given as 180 minus theta, so this is nothing but deflection angle 180 minus theta. So 180 minus theta is 120 degree, so theta will be 60 degree. So substitute the values here, 1000 into 0.001963 into velocity is 40 square 1 plus cos of 60. So you will get the answer, fx will be 4711.15 kilonewton. 4711 kilonewton. So they ask only the force exerting by the jet. Find the force exerted by the jet of water in the direction of jet. So in the direction of the jet means the jet is striking in the x direction. This is x direction. So this is the force exerting by the jet in x directions. So this is the answer. Suppose if they asked force exerting by the jet in y direction, calculate the force in y directions. So these are some numerical problems, simple problems. So practice these problems. So very simple, and here you have to remember only the equations, whether it is for the stationary case, whether the jet is striking at the center, and how it is leaving the vane, whether it is making with some angle or it is entering, at what angle. You have to identify those things and writing the given data and calculating the force exerting by the jet. Okay, so I hope you understood these problems. So let us take the next problem on a curved vein. So the problem given here is a jet of water of diameter 60 millimeter moving with a velocity of 40 meter per second strikes a curved fixed plate tangentially at one end at an angle of 30 degree to the horizontal. The jet leaves the plate at an angle of 20 degree to the horizontal. Find the force exerted by the jet on the plate in the horizontal as well as in a vertical direction. So this is the problem given. So let us write first the given data. So what are the data given here? The given data is here. The diameter of the jet is given 60 millimeter. So that is equal to 0.06 meter. Then calculate the area of jet. So area of jet will become pi by 4 d square. So that will be 2.827 into 10 raised to minus 3 meters square. Then the velocity of the jet is given in a problem, that is 40 meter per second. At this velocity the jet is striking the curved vein. Then the angle made by the jet at inlet tip with horizontal, that is inlet angle with which the jet is entering the vein, is given as theta is 30 degree, and at the outlet tip the angle given, that is pi, as 20 degree. Let us draw the figure for this given data. So this is the figure. So this is the curved vein. Then the velocity of the jet which is striking the vein at one of the tip like this. This is the velocity of the jet, that v is been given, and this velocity of the jet striking the inlet tip by making an angle of theta, that theta is also been given in a problem. So this problem is unsymmetrical case, since this curved vein is being placed unsymmetrically, and also the inlet angle and outlet angles are different, that is entry angle and the exit angles are different. So this case to be treated as unsymmetrical case. So in this case the velocity is being given and the angle with which the jet is entering the vein, that is theta, is given. So that is a 30 degree. So if we write this here, this will be 40 cos 30 and this will be 40 sin 30, because theta angle is 30 degree here. Okay, similarly here the pi is given, this becomes 40 sin 20 and this will be 40 cos 20. Okay, and also the deflection angle is also given here. Sorry, the deflection angle is not given. So this is pi, this will be theta. So this becomes the deflection angle. So this is the unsymmetrical case, and now either you can apply the impulse momentum principle for this figure and get the force exerted by the jet in x direction as well as in y directions. So we want the force exerted by the jet in y direction as well as in x direction. Okay, so with this, next, the force exerted by the jet of water in the direction of x and in the direction of y is given by, and this equation we know for the unsymmetrical case. This is unsymmetrical case. So this already we have derived. So in previous lecture, this equation for the unsymmetrical case, that is the force exerted by the jet in x direction, when we apply the impulse momentum equation, we get this equation, that is rho a v square into bracket cos theta plus cos pi. Then substitute all the data here. The rho is the density of water, then the area of the jet, the velocity of the jet, then the inlet angle and the outlet angle. All you substitute in this equation, you will get this answer, that is 8168.875 Newton. Similarly, in y direction, the jet exerting a force The formula will be rho a v square sin theta minus sin phi. Then substitute all the data here. Then you will be getting the answer 714.57 Newton. So here you have to remember the equations, or else you can apply the directly impulse momentum equation. That impulse momentum equation you can directly apply like this. Fx will be a rate of change of momentum in x direction. So that you can apply, that is mass per second into initial velocity minus final velocity. Then referring to the figure whatever you have drawn here, so you can refer this figure, and according to this figure you can apply the or you can write the initial velocity and final velocity and substitute in this equation, and you will be getting the answer. Or else you remember these equations for unsymmetrical case. Since this problem is given as unsymmetrical case, so we have applied the unsymmetrical equation here for in x direction as well as in y direction. So these are the answers. Okay, I hope you understood this problem. So let us take one more example. So in this example, it is a moving case. A jet of water of diameter 7.5 centimeter strikes a curved plate at its center with a velocity of 20 meters per second. The curved plate is moving with a velocity of 8 meters per second. Here the jet is striking at a velocity of 20 meters per second, and the plate is moving at a velocity of 8 meters per second in the direction of the jet. The jet is deflected through an angle of 165 degree. Here the angle of deflection of jet is given. Assuming the plate is smooth, find the force exerted on the plate in the direction of jet, then the power of the jet, then the efficiency of the jet. So let us write first the given data here. The diameter of the jet is given, that is d, 7.5 centimeter, that will be equal to 0.075 meter. Then calculate the area of the jet from the diameter, pi by 4 d square. So this is the answer we get. Then the velocity of the jet is given 20 meters per second. At this velocity the jet is striking the vane, and the velocity and the plate is also moving at this 8 meters per second. Then the angle of deflection is given as 65 degrees. So first draw the figure. So this is the curved vane, and here the velocity of the jet is striking at its center. Okay, this velocity is given, and after striking this vane starts moving with a velocity of 8 meters per second, and this velocity is given 20 meters per second. And then this vane starts moving, and after hitting the velocity will become the relative velocity, because both are moving. Plate is also moving and the jet is also moving, and the jet will be striking with a relative velocity, and this will be v minus u. This will become v minus u. The angle of deflection is given, and this angle becomes 15 degree. Then this will be what? V minus u sine of 15, because this also 15, and this will be v minus u cos of 15. Okay, I hope you understood this one. So the velocity of the jet is 20 meters per second. With this velocity it is striking, then the vane is moving at a velocity of 8 meters per second. Then the jet will be striking with relative velocity, that is with v minus u. With this velocity it is striking. Okay, then further, and as usual you have to apply the impulse momentum equation, and we know the equation because this equation is already been derived for the moving case. The jet is also moving and the vane is also moving. The equation, that is the force exerting by the jet in x direction, we have already derived, and we know the equation, that is rho a into bracket v minus u whole square into bracket 1 plus cos theta. And here v represents the velocity of the jet and u represents the velocity of the plate, which is been given in a problem, and theta is the angle of exit, that is because the deflection angle is given here. So here deflection angle is given. This is the total 180 degree. 180 minus 165, we get the 15 degree. So this will become the exit angle, and the velocity of the jet will be exiting at v minus u. And when you resolve this velocity, the vertical component become v minus u sine 15, and the horizontal component will become v minus u cos 15. Okay, then substitute the data here. So the rho is the density of water, 1000 into area, then 20 minus 8, 1 plus cos 15, we get the answer, this one. Then they are asked to calculate the power generating by the jet as well as the efficiency of the jet. And to calculate the power, first we have to calculate the work done per second. The work done per second will be the force into velocity, that is the force exerting by the jet in x direction into the velocity of the plate. So if the plate is not moving, if the plate is fixed, then the work done per second will be 0. Since the plate is also moving here, hence we have we get the work done here. Then Fx into u, that is the velocity of plate, multiply it, that is 1250.38 into 8, we get this much is the work done per second, and the unit is Newton meter per second. Then the power of the jet will be, because Newton meter per second is what? Newton meter will be the joule, joule per second gives you what? This will become a joule, joule per second, and the joule per second will be what? Watt. We get watt. Then the power will be written in terms of watt. That is 10003.04 watt, that is we get the 10 kilowatt. Okay, this is the power we get. Then the efficiency is what? Efficiency will be what? We get a efficiency, that is output by input. Input here giving as a kinetic energy per second, and the output is the work done per second. We have already calculated work done per second. So let us calculate the kinetic energy. This is the formula we know, kinetic energy per second, and we calculate in terms of watt. So we get this 17668 watt. Then finally the efficiency will be what? 10003.04 divided by 17668 into 100, we get efficiency of the jet as 56.6%. I hope you understood these problems. Very simple. You have to remember the equations. First you have to identify in a problem whether the problem is a stationary or a moving. According to that you have to apply the formulas. Okay, and generally these problems will be asked for 8 to 10 marks in exam. 8 to 10 marks problems these problems are. Okay, I hope you understood this problem. Practice this kind of a problem. We'll continue this some more example. Let us take the next problem. A jet of water of 60 millimeter diameter strikes a curved vein at its center with a velocity of 18 meter per second. The curved vein is moving with a velocity of 6 meter per second in the direction of the jet. The jet is deflected through an angle of 165 degree. Assuming the plate to be smooth, find the thrust on the plate in the direction of jet. So here thrust means the force on the plate in the direction of jet, then the power of the jet and efficiency of the jet. So let us take this example as a assignment homework, and the similar problem we have solved in the previous lecture. So please refer that one, and in a similar way you solve this problem. Let us take this problem as a assignment. Take a next problem. So in this problem, it has been given here: a jet of water from a nozzle is deflected through an angle of 60 degree. A jet of water from a nozzle is deflected through 60 degree from its original direction by a curved plate which enters tangentially without shock with a velocity of 30 meter per second, and leaves with a mean velocity of 25 meter per second if the discharge from the nozzle is 0.8 kg per second. Calculate the magnitude and direction of the resultant force on the vane if the vane is stationary. Okay, so here first write the given data. So what is been given here? The velocity of the jet at inlet, that is V1 30 meter per second, and the velocity at outlet V2 is 25 meter per second. Then the mass per second, that is directly the mass per second is given, that is rho AV. This is rho AV, which is been given directly as a 0.8 kg per second. The force in the direction of jet, the formula we know, Fx is mass per second into initial velocity minus final velocity, that is V1x minus V2x. First, with the given data, you draw the figure. So this is the curved vane given like this, and here what is being given, see, from the nozzle, jet of water from the nozzle is deflected through an angle of 60 degree. So the angle of deflection, that is jet is deflected through an angle of 60 degree from its original direction, means this is the direction of the jet which is entering tangentially into the passage of the curved vane. If this is the horizontal, then the deflection angle is acute angle, then that is a 60 degree. So the moment it strikes, it will deflect like this, then by making an angle of 60 degree here. So it is given as the angle of deflection 60 degree. So this velocity it is entering, it is enters, glides over the surface like this, and it exits like this. And the exit velocity is also given, that is 25 meter per second. Here inlet velocity is 30 meter per second. With this velocity it is entering, but exit velocity is 25 meter per second. Hence there will be some losses here. Because of that losses, the outlet velocity what we are getting here is 25 meter per second. And with this velocity it is exiting, but by making an angle of 60, because this is the deflection angle given. So water will be striking in this way, it enters tangentially, then it glides over the surface like this, and it exits by making an angle of 60, that is the deflection angle is given here. Then when the velocity is given here, the exit velocity, but it is making an angle of 60 degree with horizontal. Let us resolve this velocity into two components, one in a vertical direction and one in the horizontal direction. Vertical component becomes 25 sin 60 and the horizontal component becomes 25 cos 60. And the vane is fixed, it is given a fixed vane, that is a stationary curved plate. Here the jet of water from a nozzle is deflected through an angle of 60 degree from its original direction. Hence we have drawn the vane like this. This is the original direction of the jet. The jet is striking here. This is the jet like this. The jet is striking the vane and at one of the tip and entering tangentially. This becomes tangentially and deflects. This is the original direction of the jet. From this direction it is deflecting through an angle of 60 degree. Okay. So once you draw the figure, then it is very easy to calculate the force. So everything we have to refer from the figure and we have to substitute in the formula. So here mass per second, Fx will be mass per second, that is V1x minus V2x. What is the V1 here? V1 is this V1 with what velocity the jet is entering into the passage of vane. So V1x will be V1 is 30 meter per second and V2x is again in the direction of jet only we have to take. So this is the direction of the jet. So V1 is the initial velocity and V2 is the final velocity, but the component of this V2 to be taken, that is 25 cos 60, that will be V2, 25 cos 60. So we get 12.5 meter per second. Then one substitute in the above equation, directly the mass per second is given. This is a 0.8, this is a mass per second, that is 0.8 kg per second. Directly this mass per second is directly given. Substitute this one, then substitute initial velocity minus final velocity, we get the 14 Newton. Similarly force normal to the jet, Fy mass per second, v1y minus v2y, again v1y. Initially in y direction there is no velocity here, okay, there is no, this is y and this is x, so there is no velocity in y direction, hence velocity in y direction will be 0 and velocity in y direction at exit will be 25 sin 60, we get 21.65 Newton. Then calculate Fy, we get minus 17.32. That minus sign indicates the jet will be acting vertically downward. Then the resultant r equal to root of fx square plus fy square, the resultant will be 22.27 Newton. Okay, then calculate the direction of the resultant. Then the direction of the resultant, there is angle made by the resultant force with x-axis. Angle made by the resultant with x-axis, that is tan alpha is fy by fx, then minus 17.32 divided by 14, we get tan alpha is 1 minus 1.237. Negative sign means the angle alpha is in the clockwise direction with x-axis. So we get alpha is 51 degree 2.86 second. That means the alpha will be in clockwise direction. So generally we measure angle in an anti-clockwise direction, but in this case the angle to be measured in a clockwise direction, that's why it is we are getting here a negative. Then fx is a positive, fx we have got as a positive and fy is a negative. We have to draw the negative y direction, and fx we have to draw in a positive x direction. Then this is the resultant. Okay, finally we have to draw this one. Then let us take one more example. Next, a stationary vane having an inlet angle of 0 degree and an outlet angle of 25 degree receives a water at a velocity of 50 meter per second. Determine the components of a force acting on it in the direction of the jet, velocity and normal to it. Also find the resultant force in magnitude and direction per kg of flow. This is very, very important, per kg of flow. And in the second part, what is been given here, if the vane stated above is moving with a velocity of 20 meter per second in the direction of the jet, calculate the force components in the direction of the vane velocity, and across it. Also the resultant force in magnitude and direction, calculate the work done and power developed per kg of flow. So here in this problem there are two cases. The first case is a stationary case and the second case is a moving case. And let us write first the given data in this problem. What are the data given in this problem? First take the stationary vane. So the given data here, the inlet angle of the vane is given 0 degree. With this angle the jet will be entering tangentially. Outlet angle of the vane is 25 degree. Then the velocity of the jet is 50 meter per second. Then draw this diagram. This is the diagram you have to draw like this. So draw this vane, and this is fixed one. The vane is fixed here, and this is the velocity of the jet, but the angle here is 0 angle. Theta here is 0 inlet angle. So it enters and glides over the surface. Then it exits by making an angle of 25 degree here with the same velocity. And we get, when we resolve this one, we get vertical component as well as the horizontal component, v cos 25 and v sin 25 like this. So this is a stationary vane. So for this one, let us calculate fx. Fx will be, and this is a mass per second. We know mass per second into initial velocity minus final velocity. We know this formula, and mass per second is given. So we have to calculate per kg of flow. So we have to calculate 1 kg per second for flow. So directly the mass flow, that is mass flow rate is given, mass per second is given here in this problem. Substitute directly 1, then v1x minus v2x. v1x is given and v2x is equal to minus v cos 25. It is in the opposite direction of the jet we are having here. The jet is exiting opposite direction of the inlet jet, incoming jet. This jet is going out of the incoming jet. This is the incoming direction, this is the outgoing direction. Then we get finally 95.315 fx. Then similarly calculate fy. So we get a fy as here. Similarly, the force exerted by the jet in the direction perpendicular to the direction of the jet per kg of flow. Then Fy will be 1 into V1y minus V2y, where V1y is 0 and V2y is V sin 25, 50 sin 25, 21.13 we get. Then Fy is 1 into 0 minus this one, we get this one. Then the negative sign indicates that Fy is acting in the downward direction. Then finally the resultant force we have to calculate, that is R equal to root of Fx square plus Fy square. Then substitute the values of Fx and Fy, we get the resultant force as 97. Then the angle made by this resultant with horizontal, that is with x-axis, that is tan alpha is Fy by Fx. Then we get the angle as a negative. That negative sign indicates the angle to be measured in a clockwise direction like this, and this is indicates the resultant force. Then Fx we got a positive in positive x direction, in a positive x direction we got a Fx, and in negative y direction we got a Fy. Then the resultant of these two, that the angle to be measured in a clockwise direction, we get this as the resultant force. Then in that same problem, what is the next case? Is a moving vane case. So velocity of the vane u is given. So previous case was fixed case. Now the same velocity of the jet which is striking the vane, but the vane is moving with a velocity of 20 meter per second. Then the force exerted by the jet on the moving vane in the direction of jet. So here the same vane to be taken, but it is a moving, this vane is moving with a velocity of 20 meter per second, that is velocity of vane. Then the effective velocity becomes here is v minus u, because both are moving. Then the jet will be entering with a velocity of v minus u. Then it enters like this, then it exits v minus u. Again you have to resolve into two components, one in a vertical and one in a horizontal direction. That is v minus u cos 25 and v minus u sin 25 we get, and the vane is moving in x direction. Okay, so for a moving vane case we have where v1x equal to v minus u, then we get v1x, then v2x will be minus v minus u cos 25 in the like this one, which is in the opposite direction of the incoming jet. We get this one. Then finally calculate fx 1 into, that is 1 is a per kg of flow, we have to take the same, but the case is moving case. Then we get fx like this, and fy you calculate again per kg of flow, v1y minus v2y. v1y is a 0, we don't have any y component here. Then v1y is 0, sorry v2y, sorry v1y is 0, and v2y will be v minus u sin 25. Then we get this as a 12.67 meter per second. Then finally the fy will be minus sign. Then the resultant force, to calculate the resultant force, root of fx square plus fy square. Substitute the values here, we get 58.57 Newton. Then the angle made by the resultant with x-axis, tan alpha equal to fy by fx. Then we get minus angle, that minus indicates the angle to be measured in clockwise direction. Then we have to draw this one. We have got positive fx and negative fy and resultant force like this, and you have to measure alpha in a clockwise direction. Then the work done per second, this is a work done per second, fx into u, and we know the velocity of plate. This is the work done per second, Newton meter per second. The power developed, the same to be written in terms of watt. So 1.1438 kilowatt the power generation. Okay, I hope you understood these type of problems. So please practice these type of problems. Let us take one more example, so which is a very important example. So in this problem, a 60 millimeter diameter horizontal jet of water, 60 millimeter diameter horizontal jet of water at 10 meter per second, striking tangentially a stationary curved vein, smooth vein, which deflects the jet by 135 degree. Find the force of the jet on the vein and its direction. If the vein is moving at 5 meter per second in the direction of the jet, determine the power transferred and its efficiency. Also, if there are a series of veins, how will the efficiency change? Okay, this is a problem given here. So here there are three parts given. First part will be the stationary part, second part is a moving part, and the third one they asked, instead of having a single vein, if there are series of veins, how the efficiency will get changed. So let us write first the given data. The data is given here is the diameter of the jet is given 60 millimeter, that is 0.06 meter. Calculate the area of the jet, then pi by 4 d square, we get the area of jet this much. Then velocity of the jet given, then angle of deflection is given, then the velocity of the vein is given. Let us take the first case, the stationary vein. The vein is stationary, so this is the case. So the jet is entering with this velocity, but the angle is not been mentioned here. Let us assume it is entering with an angle of 0 degree. So it is entering tangentially like this. So after entry, then it glides over the surface and exits like this. But the angle of deflection is given as 135 degree with horizontal. Then this angle will be 45 degree. This angle equal to this angle. Then when we resolve this component v, one we get a vertical and one we get a horizontal, that is v cos theta and v sin theta. Then apply impulse momentum principle, Fx equal to rho a v, that is mass per second, into initial velocity minus final velocity. Then rho a v, initial velocity is v minus v cos theta. Then we get minus v cos theta here. Then we get Fx equal to this one. Then substitute all the given data here. We get this much is the force exerting by the jet in x direction for stationary vein. Similarly, calculate Fy. So this is the Fy we get, initial velocity minus final velocity, but initial velocity is 0, final velocity is v sin theta. We get 199.89 Newton. Calculate the resultant force, that is root of Fx square plus Fy square. We get this much is the resultant. Then calculate magnitude of the direction of the resultant, theta equal to tan inverse of minus Fy by Fx. We get minus angle, that minus indicates the angle to be measured in clockwise direction. So the Fx we got positive x direction, Fy we got negative y direction, and this is the resultant of Fx and Fy, and the resultant will be acting at an angle of theta, that is 22.5 degree. Then the next case is given if the vein is moving, if the plate is moving with a velocity of v, u equal to 5 meter per second. So what is the efficiency of the jet they asked? Then calculate Fx, mass per second, then initial velocity minus final velocity. Then we know for a moving case, we have to take the effective velocity as relative velocity, that is v minus u, then into bracket v minus u minus of v minus u cos theta. Then finally we get Fx equal to 120.65 Newton. Then work done per second, that is the force into velocity of the plate. Then we have calculated Fx, then multiply by the velocity of the plate, we get this much. Then the power in kilowatt, that is 603.25 is a new work done per second. Then the power in kilowatt will be 0.603 kilowatt. Okay. Then finally the efficiency of the jet will be what? Work done per second, is the output by input. The work done per second is the output. Input will be the kinetic energy of the jet. Then the kinetic energy of the jet per second, that is half rho a v cube. Then when you substitute all the rho a v, we get this much is the power, that is we get a watt. Then the efficiency of the jet, substitute here, then we get the efficiency of the jet as 42.67%. This is for a single vane. So what they ask in the problem, if the series of vanes are present, like if the series of vanes are considering, if there are series of vanes like this is the impeller, this is the shaft. If series of vanes are present like this, what could be the change in efficiency, the question. And this efficiency what we have calculated is for single vane present over the impeller. If series of vanes are present, what is the change we get here? If the series of vanes present, the change what we get here, the only change we get is a mass per second. So in previous case, the mass per second is to be taken V minus U rho a v. Here when we consider all the vanes together, the jet will be in touch with the vanes, hence we have to take the rho a v, and v minus u, initial velocity minus final velocity, then finally we get fx this much, only this is the change. Then v minus u rho a v into bracket v minus u 1 plus cos theta, then substitute all the values given, then we get the force in x direction, then calculate work done per second, again fx into u, then this much is the work done per second, then efficiency of jet, output by input, that is work done per second divided by kinetic energy per second. Kinetic energy already calculated. This is the change, that is the work done per second for a series of vanes. Then finally efficiency we got 85.35%. This is compared to the single vane, this efficiency is more. Okay, I hope you understood these kind of problems. So please practice this type of problems and solve it. Okay, thank you.